Hello everyone, I'm Cynthia. In previous episode, we explained the testing of various common household appliances like air conditioner and refrigerators. In this episode, I will talk about a new type of water heater entering modern homes, the heat pump water heater. They are mainly divided into air source and water source types, with air source heat pump water heaters being the primary type used in the households currently. A heat pump, as the name suggests, works like a pump, extracting heat from the environment for our actual needs. To make it easy to understand, it can be described as an air conditioner running in the reverse mode to heat up the air. The slight difference between a heat pump water heater and an air conditioner's heating mode is that the air conditioner transfers heat into the air to raise the air temperature, while the heat pump water heater transfers heat from the air into the water via a heat exchanger to raise the water temperature. However, the fundamental principles and basic logic of both are the same. The common water heaters on the market, like the gas water heaters and the electrical storage water heaters, typically have a 1-to-1 energy consumption ratio. Let's take electricity water heaters as an example. 1 kilowatt of electrical energy can at most produce 1 kilowatt of heat. And if the heat loss of the process is considered as well, this ratio decreases further. In contrast, heat pump water heaters, utilizing principles like air conditioners, generally can produce at least 2.5 kilowatts of heat for 1 kilowatt of electrical energy. Therefore, from the energy consumption perspective, the heat pump water heaters are more conducive to energy saving and emission reduction. Thus, heat pump water heaters have also made significant contributions to the Chinese national policy call to electricity. However, the heat pump water heaters operate based on the principle of extracting heat from outside the house for use inside. Therefore, the outside area is absorbing heat, which conversely means it is releasing cold. However, this mechanism works quite ideally in the climate of the southern regions in China, where there is sufficient heat in the air to be absorbed. But in the climate of the northern regions in China, the temperatures are very low and the ambient environment is already cold. So there is a problem. How much heat can the heat pump extract from the air that is already very cold? This requires extensive verification and testing. Additionally, during the heat extraction process, could the outdoor unit frost over and become inoperable? Furthermore, could extremely low temperatures cause damage to the components of the heat pump? To answer these questions, we need the laboratory to test the heat pump units. The heat pump water heater laboratory primarily conducts various verification and energy efficiency tests according to the two standards in China: GBT 21362 commercial or industrial use and similar purposes heat pump water heater, and GBT 23137 household and similar purposes heat pump water heater. Different testing methods are used to evaluate a unit under test from various perspectives. The main test methods include assessment of heat pump heating capacity, assessment of hot water production capacity, assessment of electrical energy consumption during hot water production, assessment of maximum operating capacity, assessment of automatic defrosting capacity, assessment of hot water production capacity at low temperatures, verification of storage tank insulation and performance, verification of water supply pressure loss, calculation of the coefficient of performance, and so on. To complete these assessments, verifications, and calculations, engineers have designed an insulated chamber to simulate real environments. This environment sometimes also needs to test the limit state of the heat pump water heater's outdoor unit, which might require extreme temperatures as low as -50 degrees Celsius. Such extreme temperature requires the test laboratory components to be designed with high level, respectively on the performance of the refrigeration compressor for creating the conditions, the insulation of the chamber structure, and the tolerance of the fixtures inside the test room. Furthermore, to meet some European Union testing requirements, the laboratory often needs to simulate daily water draw patterns. This set of standards simulates a week's water usage, involving multiple cycles of drawing water and refueling within specified time frames. This places high demands on the reliability of the laboratory equipment and the data processing capacities of the software. This is also an important challenge of engineering for heat pump water heater laboratories. Only after passing numerous rigorous tests can heat pump water heaters reach the public and become the shining star in the water heater market. GZLens Laboratory has also been involved in these crucial testing efforts. Alright, That's all for this session sharing about heat pump water heaters and their testing. Next time, I'll continue to explore the world of home appliance testing with everyone. I hope these insights into testing can help you observe our daily lives from a different perspective. That's all for today. We'll continue next time.